Very good morning to all of you. I'm here again for my next video on the topic of term symbols. So brief introduction about the term symbols. Term symbol of an electron arrangement reflects the total orbital angular momentum, total spin angular momentum and total angular momentum. So for calculating the term symbols, we are referring with the three terms, L term, S term and the J term. It represents the energy of a particular electron arrangement. So here the big difference between the term and the term symbol. If they are asking about calculate the spectroscopic term, then our answer should be 2s plus 1l. Whereas if they are asking about calculate the term symbol, then our answer should be 2s plus 1lj. So before depicting the term symbol, this is the brief background about how to write the electronic configurations and what are the different factors which are affecting them. So first one is principal quantum number, which represents the main energy level or shell in which the electron is present. So it can be 1, 2, 3, 4 or 5. Second one is angular quantum number. So for writing down the term symbol, this angular quantum number is very important because by calculating the summation of L values, if it comes out to be 0, it belongs to S term. If it comes out to be 1, it belongs to P term. Similarly for 2, 3 and 4, it belongs to D, F and G term. For the magnetic quantum number value of M, it tells us the different orientations of the orbitals in space. So for the given value, it varies from minus L or plus L to minus L. Next is spin quantum number, which refers to the spin orientations of orbitals. It has two values, plus half and minus half. One is in the clockwise direction and other is in the anti-clockwise direction. So these are the simple rules which we should opt for writing down the electronic configuration. So basically electronic configuration is built up of the electrons in the different levels in the atoms or ions, which is known as electronic configuration. So before writing down the electronic configuration, we should follow these three simple rules: Aufbau's principles, Pauli's exclusion principle and Hund's rule. First one is Aufbau's principle, which is a German word, itself means building up. So it states that when electrons organize themselves, they occupy the lowest energy shell first and gradually make their way to the higher energy level. So in this, on the right side, the diagram depicts 1s, 2s, like firstly electron will enter to the 1s orbital, then to the 2s orbital, and after the 4s orbital it enters into the 3d orbital because of the energy sequence. Next is Pauli's exclusion principle. It states that orbital can hold maximum of the two electrons which must have opposite spin, because in one orbital the two electrons should not be present with the equal spin. One should be in the clockwise direction and other should be in the anti-clockwise direction. Next is Hund's rule, which states that when the several orbitals of same energy are available, the electrons tends to remain unpaired as far as possible. It means that electrons try to remain unpaired. Thus in the ground state, an atom will contain maximum number of the unpaired electrons. So this is, I am taking the simplest example for calculating the term and the term symbol. The electron is in 2p1 and 3p1 orbital. So here we only deal with the p1 or the p1 orbital. There is nothing about the 2 and the 3 or the principal quantum numbers. So here on the right hand side, the electronic configuration of 2p1 and 3p1 orbital. For calculating the L value, summation of L, it should be 1 plus 1 comes out to be 2, which means it belongs to the D term. And for calculating the spin value, it varies from S1 plus S2 to S1 minus S2, which means it can have value of 1 and 0. So for 2s plus 1, it belongs to triplet state, and 2s plus 1, if I am taking the value of S as 0, it comes out to be singlet state. So two terms arises here, 3D and 1D. So for calculating the value of J, it varies from L plus S to L minus S. So simply by taking the values of L and S, for the L its value is 2 and for the S its value is 1. So 2 plus 1 to 2 minus 1, the values of J varies from 3, 2 and 1. So here if they are asking about the spectroscopic term, then our answer should be 3D or 1D, or if they are asking about the term symbol, then our answer should be 3D3, 3D2 or 3D1. So this is again very important information. You must know about the periodic table. you must know about the electronic configuration, because before depicting the term symbol, this is our basic step or the crucial step. Write down the electronic configuration, and we are able to write down the electronic configuration only if we know the exact atomic number of the element present in the periodic table. Secondly, we must know the concept of low spin and high spin complex, because the electronic configuration varies in case of low spin and high spin complex. So again, for the ground state less than half filled, we are taking the smallest j value for the term symbol, but if it is more than half filled, then we will take the maximum j value. So then we are able to solve the different questions which are coming out in the previous years of the GATE examination or CSIR-NET exam, only for your preparation. So first I am taking the example, the ground state term for the vanadium 3 positive ion is. So for the vanadium, the atomic number is 23, and for writing down the electronic configuration of vanadium, it is argon 18 4s2 and 3d3. But by removing the 3 valence electrons, the electronic configuration will become argon 18 3d2. So writing down the electronic configuration, then calculating the value of L and S. For its value of L is 2 plus 1, that is 3, it belongs to F term, and for the value of S, it is half plus half, that is 1. So 2s plus 1, it means it belongs to triplet state. So our answer will be 3F, that is A. Next is ground state term for the nickel H2O6 2 positive is. So for the nickel H2O6 2 positive, write down the electronic configuration D8. Correspondingly, the value of L, that is summation of L, it comes out to be 3, belongs to F term, and for summation of S value, it comes out to be half plus half, that is 1. So it belongs to triplet state. So its ground state will be 3F. Then again I am considering the splitting of 3F term into the 3A2G, 3T2G and 3T1G. So there are the possible two splittings, in which one is 321G is the ground state and in another 3A2G is the ground state. So how will you depict that 3T1G is the answer or 3A2G is the answer? So its answer came from the group theory, that is the direct product. For the D8 electronic configuration, its electronic configuration is T2G6 EG2. T2G6, it belongs to fully filled, so A1G, and for EG2 its direct product is 3A2G plus 1A1G plus A1EG. So here our answer came 3A2G. So our answer will be C. So for the next term symbol for the ground state of the nitrogen atom is here also 2s plus 1 Lj. So by carrying out the value of summation of L, again it comes out to be 0, so belongs to S term. For summation of S value, it comes out to be 3 by 2. And for the J value, here I am taking the value of J is L plus S, because it is half filled. If the orbital is half filled or more than half filled, then the maximum J value should be taken, and if the orbital is less than half filled, then L minus S value should be taken. So here our answer comes out to be D, 4s 3 by 2. For the next, the possible J values for the 3D term symbol is. So for this, for the 3D term symbol, the value of L is 2, and for this S value is 1. So for calculating the J value, it varies from L plus S to L minus 1. So 2 plus 1 to 2 minus 1, 3 to 1. So the possible J values total are 3. So our answer will be B, that is 3. So the next question, the ground state for the samarium 3 positive and europium 3 positive are. Again here very important topic is samarium 3 positive and EU 3 positive, it belongs to lanthanide ions. So you must know about the electron atomic number of samarium and europium or electronic configuration of samarium and europium. Then only you are able to calculate the term symbol, because the calculation of term symbol is very easy, but problem arises, you must know the atomic number, you must know the electronic configuration, then only you can easily depict the term symbol. So here for samarium 3 positive, the electronic configuration is xenon 4f5. So for writing down the electronic configuration and summation values of the L, it comes out to be 5. So 5 corresponds to the H orbital. Similarly for the S orbital, summation of S, so here the values of spin state is plus half, and there are the different 5 values, so it comes out to be 5 by 2. So for calculating the spin multiplicity, it is 2s plus 1. So here by calculating the value of 2s plus 1, it is 6. So by this configuration, here the term symbol will be 6H 5 by 2. Similarly, by applying the same formula, you are able to calculate the value of EU3 positive. This is your practice question, and make sure practice a lot of questions about the term symbol, and it's a very important topic for the CSIR-NET exam, and every time the question came for the 2 marks, for the 4 marks. So hopefully you will like this video. Thank you so much.